Hello developers. In this video we will introduce the concept of unit testing, discuss some terminology and philosophy of testing, and introduce the JUnit framework for testing Java programs. If you'd like to know more about testing, and I hope you do, here are some books that I recommend that I have found very useful. I think that you should look at books that are not specific to a particular programming language, rather that focus on testing, how to do tests, what are good tests, how to judge when things are tested properly, to get a good foundation in the philosophy and theory of testing software. This will make you a better developer, even if you don't end up writing test programs. We see the term regression testing quite a bit in software development. It doesn't mean quite the same thing that it does in statistics. Rather, it means that when you add something or modify something in an existing product or a product being developed, you may break something else. In other words, your software may actually regress in quality. That's why we call it regression testing, because we are testing all of the aspects of the program that we possibly can, even if we just made a change to one part of the program. We want to find out if we broke something else in the process of doing something completely unrelated. Some things to think about when you're writing tests. Tests have to be repeatable. We talk about using random numbers sometimes to generate test data. That's perfectly fine in most cases, but be sure that those numbers are not completely random, meaning that if you run the test again tomorrow, you will need to generate those same numbers again. If you're using completely random test data every time you run your tests, that makes reproducing results problematic. And if you break your program, you will have a difficult time reproducing the situation that caused that failure if you can't get that same quote unquote random data back again. So repeatability is crucial. Tests should be easily interpreted. I should be able to look at the results of a test and understand within moments whether or not it passed. Now, that doesn't mean that I understand why it failed and that I might need to spend 3 days fixing it, but I need to know right away, without having any background or knowledge of that particular program and what it's testing, whether or not the test was successful. Boundary conditions. What are the maximum and minimum values, numeric values, string values, time, date? What are the upper and lower limits of things that could possibly be submitted to that code? What input values will stretch the limits of the computations that code is performing? Those are boundary conditions. Those are something that we always want to test, because we can generally break the code at the boundary conditions. Don't test your own code. And then immediately below that, I write, do test your own code. I'm making the point here that the philosophies differ on that. Some companies will have you write your own test code. Some companies will have other developers writing test code for you against your code. So be prepared to discuss and to have an opinion on whether or not it's a good idea to write your own test cases or have someone else with less of an emotional stake in the code writing test cases. There's two ways to go there. We use the term unit testing. A unit we will define as the smallest testable part of a program. For you, that should be a method. You should be able to write tests that exercise a method completely and thoroughly. If you find yourself writing methods that are too big to test, then your methods are too big and they need to be broken up. They need to be modularized. We talk about a reasonable goal of a method being no bigger than one screen, so you don't have to scroll up and down to read it. Another goal, a method is no bigger than what you can reasonably write test codes against. So that's a unit. A unit test is a piece of software written expressly to test that unit of code. It's not part of the final product. You won't be shipping it. The customer will never see it. But it is a crucial part of development because it makes sure that that little unit of code works as best as it can possibly work. Another term that we use sometimes is test coverage, meaning that we calculate using some metric how much of our code has been tested. Now this varies and it's difficult to measure with 100% accuracy because code paths balloon dramatically. Every time you add an if-else statement to a piece of code, you double the number of code paths that are available to be tested. If your program has 10 if-else expressions, that's 2 to the 10th code paths, and 2 to the 10th is a very large number. It becomes impractical to test every code path with every boundary condition. The test program simply would never finish. So test coverage could be measured in different ways, not simply by the lines of code or the number of code paths that are tested. TDD, or test-driven development, is a philosophy of software development that means we create a set of tests, and when your program passes those tests, it is considered to be correct. Those tests will probably not come from you as the developer in the case of TDD. They will probably come originally from a systems analyst who hands it down to a different developer who codes those tests and then subjects your units to those tests. TDD is an acronym that is used to create job listings in a lot of cases. You may see a developer listing where they're asking for a Java programmer who has TDD experience. So if you see that acronym, now you know what that means. The concept of a side effect is important in testing. Every method that we write must have at least one side effect. On the slide, the first method has a side effect in that it sets the value of a class level variable. The second method has a side effect in that it prints something to system.out, which is typically the console, maybe a screen, maybe a printer. Those are side effects. Those are things that happen outside of the code inside that method. We're generally testing side effects. We really don't care, at least in general, what goes on inside the method as long as it produces the desired side effects. If a method has no side effects and it does not return a value, it's considered non-functional and we don't need to test it, and we wonder why it even exists because it doesn't actually do anything. So that would be considered a non-functional method. It would immediately become suspect because we wonder why it even exists in the code. Another philosophy of testing is, when do we stop? What does not need to be tested? On this slide, we have a one-line method that takes an argument and stores it in a class level variable. Does that need to be tested? Well, that's something you need to think about. We can make arguments both ways. What I want from you is to have an opinion and to be able to talk about that intelligently. Why does that need to be tested? Why does that not need to be tested? Come down on the side of one or the other. Another philosophy of testing is who should write the tests. We have a developer who's worked long and hard to create methods and logic and implement designs and has some understanding of the intended purpose of the system. Should they write the tests? In other words, should they be testing their own code? On the other hand, we have people who could care less about your code, who might not even like you or might not even know you, Maybe they are the ones to test your code. Who should write the tests? When should the tests be written? Before the code is written? Do we know enough about the system to write those tests at the unit level? Should the tests be written as the production code is developed, as we're learning about what the production code is doing at the unit level? Is that a good time to implement tests? The tests are right in the front of our mind because the logic and behavior of those units is right in the front of our mind. Should the tests be written after the production code is perhaps getting close to being finished? Maybe it's too late then. Maybe we would find some errors that we would have otherwise found earlier if we'd written the tests earlier in the process. Again, think about these things, read about them, and have an opinion on what might be a good idea and what might not be such a good idea. As we mentioned a few slides back, you have an emotional attachment to your code. You don't want to see it break. It hurts you when it breaks. You've worked long and hard on that code. Maybe you're not the one that should write the test cases. Maybe we should find someone who is on the other side of the world, who's never met you, and let them take a shot at breaking your code. Maybe they'll get more satisfaction out of it. They'll be more focused on finding mistakes, and they'll be the one to show you where you need to fix your errors. Some people are so wedded to their code and so emotionally attached that they will never be good at writing their own test cases. They're just not the right one to do it. What do you test? What data do you provide to a method? What conditions do you create to try to cause a failure? There's two broad categories. The first category is create a set of inputs, create a set of conditions to replicate expected behavior. If you're testing a program that reads keystrokes, you want to feed keystrokes to that program at the rate a human would type. That's a reasonable expected behavior for that program to be able to handle. What are the boundary conditions? Sometimes called corner cases. Those are the things that might not happen all the time, but when they do, will probably put the most stress on your logic. We certainly want to test boundary conditions. And one of the reasons we do is because generally we find errors at the boundaries. On the slide, I've provided you a very conceptually simple method that takes one integer argument and returns a Boolean, and based on the name of the method is prime. You can probably guess that that method is going to return true if the argument is prime. As a tester, as a testing engineer, as a test developer, what are 4 reasonable boundary conditions that you might provide to test this method? And what I mean there is, what are 4 values of that parameter that you might feed into this method as part of your test scenario? Take a moment now, stop the video, and think about that, and I will wait for you. Are you ready? Did you come up with 4 reasonable test cases? How about the largest positive number? We want to know if our program can handle the largest possible positive number. Now we're going to learn a lot about our program, about our unit, by testing that number. We're going to learn whether or not it takes 3 days to process that number, and that might tell us something that we need to fix, or that that's not an issue in any way. How about the largest negative number? Does our program have to support negative numbers? Can we even have a negative number that's prime or non-prime? That's a math question. I don't have a specification. All I have is that little method stub that I showed you on the slide. So I'm assuming that that method has to handle negative numbers one way or another. 0. 0 is a good boundary condition. It's a kind of a weird number. Is it prime? Is it non-prime? Well, I'd better know the answer to that if I'm writing that method. 1. 1's another weird case because the definition of a prime number is any number that's divisible by only itself and 1, and the number 1 is certainly divisible by itself and by 1, but oddly enough 1 is not considered prime. There's a weird boundary condition that would have to be tested. Let's throw in a few more. The largest possible prime number. Now, we in number 1 suggested the largest positive number, but I'm not sure off the top of my head whether that is prime or not. I would want to do some checking, and maybe the largest possible positive number is not prime, and I need to back up a little bit to find the largest possible number that is prime. That would be an excellent boundary condition. And then, of course, as you can probably guess, the largest possible negative prime would be another good boundary condition. So there's 6 possible boundary conditions right off the top of my head for that particular method. Notice that I need some knowledge of mathematics and prime numbers to be able to come up with these test cases. So perhaps you might be the one to develop this method, but you might not be the one to generate the test cases because you simply don't have the math knowledge. There's an example of a good situation where someone else with more math knowledge and perhaps not as much programming knowledge would be a better person to come up with the test cases. We are going to use a testing framework called JUnit. As of this writing, JUnit 5 is current, and I encourage you to visit the JUnit 5 website and take a look at the documentation and read about the history of the product. It's a very popular product used in Java testing situations, and it is part of Eclipse. Therefore, if we have a modern version of Eclipse, we automatically have JUnit, and we can make use of it with very little effort. It's a powerful tool, it's well understood, it's popular, and it comes up a lot in job searches. As a matter of fact, let's do a very brief search using a job website, dice.com, and let's see how many jobs literally list the term JUnit as part of their qualifications. Well, I got 258 jobs that specify in one way or another the word JUnit. The very first one actually lists JUnit as part of the job description title. So you can see whoever this employer is thinks it's very important that their developer know how to use JUnit. This is important to us because we're learning to use tools that are in production in the real world, and that makes us more valuable as employees. I'm going to walk through creating a very simple project just to show you how to do it. And I want to emphasize that the first time we add JUnit to a project, Eclipse will ask us if we want to build that into the build path of that product. And you can just watch me do this, or you can follow along if you like. That's great too. Here I am in Eclipse, and I'm going to just create a throwaway project. So new project. I'm going to create a Java project. There are some philosophies of testing that would suggest that the unit testing project is completely separate from the production project. I am going to keep mine together, and I'm not saying one way is better than the other, and I'm not saying it's something we want to argue about, but just be aware that sometimes you will create a unit testing project separate from the code that you're actually testing. I'm going to call my project unit test demo. And I am going to add in the source folder other. So instead of adding a class or a package, I'm going to select other. And then in the wizard search bar, I'm going to type JUnit. That way, if I forgot where it was in that big list of templates, I can find it easily. I type in JUnit, it filters down the things that I can add to JUnit test case and JUnit test suite. We're going to add the JUnit test case, it's simpler. And I'll create a package. And I'll give it a name. I called the package JUnit test package. I called the name of the test case JUnit test. I'm going to make that package name lowercase just because Eclipse is happier about that, and that is the convention in Eclipse and in Java to have packages start with a lowercase letter. I'm not going to go into any of the other details here, but you can create additional classes to scaffold your test. You can create logic that will run before the tests, logic that will run after the tests. You might want to open a connection to a database or create some test data. Do things that you only want to do once that aren't typically part of the actual testing process. We're not going to do that now, but this is where that would go. Now, as soon as Eclipse realized I was adding a JUnit test case, it checked the build path and it noticed that it's not including the JUnit framework, and it offers to let me do that. You can say no, I don't want to do it, meaning that you'll do it later. You can go into the build path property page and manually configure it now, or you can let Eclipse add it to the project for you. Certainly the path I'd like to take, let Eclipse do the work. Good. Now I have nothing else in this project except one unit test. The first thing you'll notice that's different is that there is a decorator @test, which tells Eclipse and tells the JUnit framework that the method following the decoration will be a unit test to be executed as a unit test. They also went to the trouble of adding one line of code to this unit test, and this one line of code is guaranteed to fail the test. And the test will fail with a message not yet implemented, so you can't make a mistake. If you try to run this project right now, there's one test in this project, and that test is set up to fail under every circumstance. And that's what I like to do now, actually, is run this test for you. If you open the Run menu and you look at Run As, you will see the choice JUnit test. There is no main in this project. There is no other entry point to begin executing, so our only choice is to run it as a test using the JUnit test framework. Let's do that. And hopefully on your machine another window opened and the results of all the unit tests are displayed in that window. Remember back on the slide I mentioned that tests should be easily interpreted. Well, JUnit tests are very easily interpreted because they either fail or they pass. At a glance, I can tell that I ran one test and it failed. One failure, and then if I'd like to drill down, I could see the individual test cases that would be enumerated in this tree. Very easy to interpret the results of the tests. Again, might be difficult to fix, but it's easy to tell at a glance whether they've passed or they failed. Okay, that was a good introduction to creating some JUnit tests, but let me show you one more thing. If I accidentally close the JUnit tab. It's gone now, and I'm in a mild panic because I don't know if my tests passed or failed. You can go to the Window menu and go to Show View. And if you don't see that JUnit window under the Views, just select Other. And then you may have to search for it, but you can always restore that view to your screen. So remember, Window, View, and then if you don't see it in the list of views, select Other and go ahead and search for JUnit, and you can easily restore that tab. At this point, you should stop the video, and if you have not already done so, load the donor project into Eclipse, and we'll talk about that project together. I have it here already in my Project Explorer, and you should go ahead and do that now. Returning back to the slides again, I'm going to skip over this slide, and I'm on slide 17 now, and I see that we have loaded the project into Eclipse, and I'm showing you the architecture of that donor project. There are 3 packages, a package called Fish, a package called Main, and a package called JUnit Tests. And in that JUnit Tests package will reside the unit tests that we choose to write. That should look familiar to you because we just a moment ago created a project with unit tests in it. Let's assume that we're writing a test against this specification for the Fish class. The specification states a fish object cannot have a blank name. So the systems analyst that designed this system talked to the customer, and the systems analyst has realized that we can't create a fish unless it has a name. That sounds pretty simple. Well, how do we go about enforcing that? And how do we go about testing whether or not it's being enforced correctly? This is the class we want to test. It's called Fish. It appears in the donor project that I gave you. It's very simple because all we're concerned about now is testing that one item from the specification. There's a constructor. You can see from the constructor right away we have a problem. We're violating the spec. If we call that constructor, the constructor by default creates a blank name for the fish, a violation of the spec. Of course, we've done this on purpose because we want to create some unit tests and to see the failure of that unit test. Here are the unit tests I provided in the donor project. The first unit test creates a new fish object and then immediately calls a method called assert. Now the assert methods are supported by the JUnit framework. What we're saying there is that this expression inside the parentheses must be true. We are asserting that it must be true. If it is not true, the assertion fails and that test fails. That is our test. The expression that we have inside the parentheses is that the getName method returns a string. The length of that string cannot be 0. So we're testing that specification requirement that a fish cannot have a blank name. If the fish has a blank name, the assertion fails, the test fails. The second test, and you'll notice this one's called test 1. That's just a made-up name. You can call it anything you like. In the second test, we create a new fish object. We immediately set the name of the fish object by calling the setName method, and we do the same assert, but in this case we're asserting that the fish name must be what we just set it to. We set it to perch in the previous line, and in the assert line we're retrieving it using getName and we're saying it must still be perch. I'm testing that the setName method works correctly. If the setName method does not return perch, then that test fails, the assert fails, and that logs into the JUnit framework. In the third test, I'm testing the constructor to see if the constructor stores the fish name properly. So in the constructor, I'm passing bass as the argument to the constructor, and in the assert, I'm calling the getName method and comparing whatever that method returns with BASS to see if that works. So I provided 3 tests. They exercise the constructor, they exercise setName, they exercise getName, and they make sure that we can't have a blank name for a fish. On the next slide, we see what happens when we run the tests. We can tell at a glance that we ran 3 tests. We can tell at a glance that one of them failed. This test result can be interpreted by anyone in the company who can read English. You don't have to be a computer scientist. You don't have to be a programmer. You can be anybody assigned to read the results of the test. That's why the test framework is so powerful. Anyone can interpret the results of these tests. We can also see that by the colors, which one failed and which one passed. The one that failed is in blue. I don't know why. You'd think it'd be in red. And the 2 that passed are in green. So test, the method called test, failed, as we expected it would, because we asserted that the name of the fish would be non-zero, or with the length of the name of the fish would be non-zero, and we knew that in advance it was going to be blank, so we knew that test was destined to fail anyway. What happens at this point? We send this information back to the developer along with a copy of the specification and say, look, your code doesn't match the spec, fix it. We don't have to change the test, folks. The developer has to fix their code. The tests run again without any changes, and until all 3 of those tests pass, then this unit is not considered to be correct. On the next slide, here's a challenge for you. Without making any edits to the fish object, I ask you the question, can we create a fish object with a name and then erase the name later? If that's true, if we can do that, we're violating the spec, because the spec said the fish cannot have a blank name. So, how do we add a test to the unit test framework? Flip back over to Eclipse, and we're going to try to answer this question by setting up a test. Again, we're not changing the fish package. We're not changing the fish class. That's not our responsibility. Our responsibility is to write the test cases. Open up the test case file. Underneath the last test, that's a convenient place. Let's create another test. I've created a test called test 3. I decorated it with the @test decoration so the framework knows it is a test. And then it's up to you to write a test to verify this question. Can we create a fish object with a name, then erase the name later? We should not be able to do that because that would violate our spec. What I want you to do then is to write that test case right now, and I will wait for you. Are you ready? Here's my code. In my test 3 method, I created a fish. The instance is called myFish. In the constructor, I initialized the name of the fish to Guppy. And then immediately on the next line of code, I called the setName method to set the length of the fish, to set the fish name to blank. So I violated the spec in line 42. Fish should not be allowed to have a blank name. Something should prevent that from happening. Then in the very next line, I put my assert, and I actually copied the assert from the very first test that we wrote up on line 23. The fish name, calling the getName method should return something that's in length greater than 0. So this test will fail because I, in the previous line, set the name to blank, which has a 0 length. That's all I have to do. Now my framework has 4 tests, and I can go up to the drop down on the little green Run button, and I can select Unit Test. Notice that this is a little more confusing because there is a main class with a main method in this project. Therefore, there are 2 potential entry points in this project. This project could run from the main, the way most Java programs do, or it could run as a framework, a suite of unit tests. So I have to tell Eclipse to run it as a unit test. I can do it from the Run menu, click on the little green button, the drop down next to the button, or I can go over here and right click on the project and say Run as Unit Test. When I do that, it thinks for a moment, and just like we thought, it runs 4 tests and 2 of them fail. You can see in the panel that the first test failed just like it did a few minutes ago, and the last test failed because we violated the spec and we let the fish have a blank name. So this is a good unit test because we tested the ability to create a fish with a name and then come back later and set the names to blank. The next thing that would happen is you would write a report or send a copy of this screen or some other communication to the development team, and they would decide how to fix the problem, because we've certainly not followed the spec when we implemented this fish class. Returning back to the slides again. Here's another test case we could add. Can I have a fish name that is all blanks? We've kind of done that already, and we might be able to make the case that, hey, we're already testing this condition, but there might be something where we could call some other method or some other way to get a blank name into the fish object other than calling setName. Can you think of a way to do that? There is another way that we haven't tried to get a blank name value into the fish object. And I'll give you a hint. We need a test case that passes a blank name to the fish constructor. We haven't tested that yet. That would obviously be a violation of the spec, because the spec says the fish can't have a blank name, and we have not tried that. We've tried passing a blank name to the setName method, and we know we can do that, which is a violation. We haven't tried passing a blank name to the fish constructor. That would be another test we could add to this suite of tests, and I will leave that up to you as an exercise. I hope you've got some interesting information from this video. I encourage you to practice writing your own test cases again, and I encourage you to think about the philosophical issues that we have discussed here. If you're in a job interview, be ready to talk about testing. Do you think you could test your own code? Would you prefer somebody else wrote the test cases for your code? What needs to be tested? What needs to be tested, rather? When should the tests be written? These are all things you should have some thoughts on. We won't expect you to be 100% correct. Many of these things are open for discussion. So don't think that there's 100% right and 100% wrong answers for these questions. They're discussion points, and they're things that you should be able to talk about intelligently in a job interview and standing in line at Chipotle. Thank you.